Welcome everyone. In this video, you will master NumPy. NumPy is the backbone of data science, machine learning, AI, and scientific computing in Python. If you want to work with arrays, matrices, statistics, or performance optimized code, NumPy is a must. No advanced math required, just basic Python. Let's get started. What is NumPy and why use it? NumPy stands for numerical Python. It provides a powerful object called an ND array, which is faster and more efficient than Python lists. NumPy is used because it's faster than lists, memory efficient, built for numerical operations, and widely used in AI and ML libraries. Before we start, make sure you have NumPy installed. Open your terminal and run pip install NumPy. If you don't have a Python environment set up, Anaconda is the easiest way to go. So let's install NumPy on my system. I will click on the terminal here and terminal will appear. So you can see NumPy is not here, and if I run this program, it will throw error. So I will go to the terminal and install pip install NumPy or NumPy, enter. Installing collected packages NumPy. It is successfully installed. Now import NumPy as NP. Import NumPy as NP. So we are aliasing NumPy as NP. Then print the version of NumPy NP dot underscore underscore version, and it should print the NumPy version. Run it and it printed 2.4.2. Let's see how we can make a Python array equal to 1, 2, 3. So this is the Python array and print array, run it, and it's printing the 1, 2, 3. If I want to multiply this with 2, if I write it start 2 and run it, it's not multiplied all the elements by 2. In fact, it's repeated the values 1, 2, 3 and again 1, 2, 3. So to multiply the values in Python array, we need to use for loop, but it's much simpler in NumPy, and we will see the example in this video. NumPy is built around one central object, the ND array. An ND array is an n-dimensional array. It allows you to store data of same type in contiguous block of memory, which makes it incredibly fast and memory efficient compared to Python lists. To get started, we will import NumPy as NP. So we have already done import NumPy as NP. We create an array by passing the list to the NP array. So we can NP array and pass the list, and this will create the NumPy array. So it is much simpler in Python to create the NumPy array, and if we print it, it will show the array 1, 2, 3. And also we can provide the data type here. D type equal to float 32. So now it is creating the NumPy array with the data type float. Notice that I specified dtype float. This forces the data into 32-bit floats. If you try to store string in strictly typed NumPy array, it will throw an error. This is the key difference from standard Python lists. And let's see, if I pass the A, it should throw an error. Value error could not convert a string to float A. So this is the error. We cannot pass a string to float type NumPy array. So simple example could be like this: array equal to np.array, and the data we can also do like this: data equal to 1 2 3 and pass the data here. So it is now complete, and print array. So it printed the array. Now we can check the D type. So D type is float 32. So data type is float 32. Let us see the different ways to create the NumPy array. np dot from a list. So you can create NumPy array from a list. lst list equal to 1 2 3 4 and array equal to np dot array and list. So we created the array, np array. Let's run it. It's 1 2 3, and you can see in the list we have commas, but here there is no comma. Suppose you want to fill the np array with zeros, then you can use the function called zeros. Print np dot zeros, and I want 5 zeros. One, two, three, four, 5. It printed. It created an array. It created an NumPy array with 5 zeros. Then we can also use the ones. It created NumPy array with 1 1 1 1 1. We can also create the two-dimensional array by this way. Ones, 2 by 5, and run it. So this np.once, and it's a two-dimensional array. Let's run it. So it is creating the two dimension and filling all with zeros, and it's a matrix of 2 by 3 matrix. Now we can see how we can use the range values. As np.range 1 to 10, run it. This arrange. We have to use a range method, np.arrange, and start then stop. So it is starting at 1 and ending at 10. So it created the NumPy array with 1, 2, 3, 4, 5, 6, 7, 8, 9 values and excluding the 10. If you want to include the L10, we need to make it 11. So now it is 1 to 10 and the last number is excluded. Now there is third parameter is step. So I want the step 2. So it will create the 1, then it will skip one value, then go to the third. After third it is skipping 4, and after 5 it is skipping 6, and similarly 8 here till 9. If I make the step to 1, it is going to print all 1 to 10. If I make it 3, it's going to print 1 and it will speak two numbers. Now I will show you how to generate evenly spaced values. For this, array equal to np dot line lin space 0, 1 and 5. Run it and print array. So it created the 5 numbers 0, 1, 2, 3, 4. I mean 4 numbers between 0 and 1. So if I want if I want 3 numbers, then I need to write 4. So it is going to 0, 0.33, 0.666 and then 1. So it is creating the evenly spaced values. Now we will see about the array properties. So let's learn the array properties. NumPy arrays comes with built-in properties that describes their structures. Let's create a two-dimensional array np dot array, and first dimension, second dimension, 1 2 3, second row 4 5 6, and let's make the third row as well, 7 8 and 9. So it's a matrix of 3 by 3, 3 rows, 3 rows and 3 columns. And let's print it. Print array, and this is the output: 1 2 3, then 4 5 6, then 7 8 9. Now the properties are dimension. So how we can get the dimension? Using the shape. Using the shape we can get the dimension value. Shape is 3 by 3. Next is number of dimensions. So this is printing the number of dimension. So number of dimension is 2, because it's a two-dimensional array. Next, the total number of elements. For this we will have to use size. So it is going to print total number of elements. So it is 3 3 3. Total is 9 elements. And now we will get the data type. Print d type. So this is going to print the data type. So it is integer 64. If I make it as a d type 32, then you see the data type will change. So data type is float 32. So this way you can create two-dimensional array and find its shape, its dimension, size means number of element, and the data type of NumPy array. Now we are going to see the one-dimensional array. Import NumPy as np, then create one-dimensional array. Let's see, let's call numbers. Numbers equal to np dot array, and list is 10 20 30 40 and 50. Now we can print the numbers. So it is printing the NumPy array 10 20 30 40 and 50. So we have already seen the properties of NumPy array. We already seen the properties like shape, endim, size and d type. So these are the properties of one-dimensional array. These are the properties of NumPy array: shape, ndim, size, and dtype. Shape is going to give you the dimension, ndim is going to number of dimensions, size is going to give you total number of element, and dtype is equal to, and dtype will give you data type. So run it and you will see it's giving you the number of dimension, then total number of element and data type. Now let's see how we can access this element. Print numbers 0, first item, first element, and to get the last element you need to give -1. This will give you the last element. So first element is 10, last element is 50. Let's print the numbers. Let's print the numbers and see. So first element is 10 and last element is 50. Now we will see about slicing. Slicing in NumPy. Print numbers from 1 to 4. So this is the start position colon, then the end position. So it will print second, third and fourth. Second, third and fourth items it will print. Now we will see the mathematical operations. Print numbers plus 5, numbers asterisk 2. So print numbers plus 5. So it's going to add 5 into each element and then print the numbers plus 5 is going to add 5 in each element and then print. And second is numbers star 2 is going to multiply all the elements by 2. Plus 5. So it added 5 into each element and second is multiplied by 2. This is the mathematical operation that we can perform on NumPy arrays. And now we can see the useful functions. Numbers dot sum, there is a sum function which is going to create the sum of all the elements and print. Then there is a mean method which is going to the min value, and there is a max as well. which is going to give the maximum value, and mean will give you the mean value of all these items. Max is going to max value, and for minimum we can have, for minimum we use min method. So let's run it, and all these are printed here. Sum is 150, mean is 10, 30, max is 50, and minimum is 10. So we can perform all these operations on NumPy array. We can see one real world example. Daily sales equal to np dot array, and here we can provide the sales values. So we created the daily sales NumPy array. Now we can find the total sales and average sales. Print total sales is equal to daily sales sum of daily sales and average sale So this is one example to calculate the total sales and average sales from the data. Or we can put comma here, right? And it should work. Total sales 9,200 and average sale is 1,840. Now I will show you how you can create 2D arrays in NumPy. So import NumPy as np, then matrix, np dot array, 1, 2, 3, 4, 5, 6, 7, 8, 9, print matrix. So it's a two-dimensional array. So this represents 3 rows and 3 columns like a table or matrix. Now we will see the properties of 2D array. Dot shape, dot and dim dimension, size, and data type. So these are the properties of two-dimensional array in NumPy. So it's printed 3 3, then 9, 3 3, then 2, ending is 2, size is 9, and d type is integer 64. Now I will show you how you can access the values. First row, first column, first row, oh, first set, I mean 0th row and 0th column is going to be 1, then first row and second. Let's run it. 1 and then 6. Zero, 1, 2. This is second one. So in this 0, 1, 2 is 6. Now we will see how the slicing. Zero, 2, 2 in the row and 1 colon 3. So it's giving the 2, 3 and 5, 6. 2, 3 and 5, 6. So in a first 2, 3 in first row and 5, 6 in second row. Now we will see the mathematical operation. So in mathematical operation, multiply by 2. So it is going to multiply all the elements by 2. And if I add plus 10, it's going to sum or it's going to add 10 in all the elements. It was 1, then 1 plus 10, 11, and similarly last was 9, 9 plus 10, 19. And for multiplication, 1 is 1 into 2 is equal to 2, 2 into 2 equal to 4, 3 into 2 equal to 6. So this way is multiplied it. So we can perform the multiplication operation as well. Now we will see row and column by operation. Rows and column wise operation. So matrix dot sum axis 0. So it provided the sum like this. So first is 1 plus 4, 5 and 7, 12. Then this one first is added this one this way, and in second it is added this way. 1 2 3 equal to 6, 4 5 6 equal to 15, and 7 8 9 equal to 24. So this way you can specify the axis and it will calculate the sum based on the axis. Now we will see how to reshape a 2D array. So let's create another array. Here are equal to np dot arrange 1 to 7. So this is 6 elements, and reshaped equal to arr dot reshape 2 into 3. So it printed the reshaped array. Original array was this is the original array, and it reshaped into 3 into 2. 1 2 3 4 5 6 element, and 3 and 3 6. Reshaping and dimensions. One of the most powerful features of NumPy is the ability to reshape your data without changing the underlying data values. Imagine you have a list of 12 numbers. You can treat it as 3 into 4 grid, 2 into 6 grid, and or even a single row of 12. The reshape method takes a tuple as an argument. We can also use flatten to squash the array back down to 1D list. You can also create specific NumPy shapes or identity matrices for linear algebra. Let's see another example. Grid is equal to np.array, np.arrange, and we have 12 elements. Print grid. So we have 12 elements starting from 0 to 11. Now we can reshape it. Grid dot reshape 3 into 4. Print reshaped. So this is the reshaped two-dimensional array. 0 till 11. So this is in 1 2 3 4 4 into 3 matrix. Now we can also flatten this dot f flatten, and is going to create the original array, one-dimensional array. Now we can see the Boolean mask as well. Boolean mask is equal to arr greater than 5 and print Boolean mask, and it is printing false, 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 and from here it is greater than 5, so it is printing true. Now we will see about the broadcasting. This is the moment you realize why NumPy is faster than loops. Broadcasting allows NumPy to perform arithmetic operation on arrays of different shapes. Rule 1. Operands must be compatible. Rule 2. If dimensions don't match, NumPy will stretch the smaller array to match the larger one. This allows us to do complex math in single line without writing a for loop. This is vectorization, and it is essential for high performance. Now we will see the broadcasting example. Matrix equal to np.array, 1 2 3, 1 2 3, 4 5 6. Now we can multiply it by 10. Matrix stars 10, so it is multiplied by 10. So all the elements is multiplied by 10 and is very fast. Now we can create a vector. Four 5 6. Now we can add these matrix plus vector, and this is the output. 1 plus 4 equal to 5, then 2 plus 5 7, and 3 plus 6 9, 8 4 plus 4 8, and 5 plus 5 10, and 5 plus 6 plus. So this is the example of broadcasting in NumPy. Now we will see about indexing and slicing. Indexing in NumPy is similar to Python lists but more powerful. Indexing and slicing in NumPy is similar to Python lists, but it goes much deeper. You can slice across multiple dimensions simultaneously. Standard slicing uses the syntax start, colon, stop, colon, step. But here is the killer feature, Boolean indexing. This allows you to select elements based on logical conditions. If you select a subset of matrix, NumPy creates a view of the data, not a copy. This is a memory optimization technique, but it means modifying the view changes the original data. Here are equal to numpy.array, 1 2 3 4 5 6 7 8 9 Now we can create a subset equal to array zero colon 2, then 1 colon 3. So this is the subset. So subset is 2, 3 and 5, 6. From 0, second position, and from 1, third position. So this is a subset 2, 3 and 5, 6. So Boolean mask, it is masking, and Boolean mask equal to error greater than 5. Print Boolean mask. So it is printing false, 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 then true, true, true. Now we will see about the indexing. ERR equal to NumPy dot array ten, 20, 30, 40 and print ERR position 1. So it's going to print 20. So this is the accessing the element by index. Slicing is from 1 to 3 print. This will print the item from first position, second, this one. It will print the items 20 and 30. 20 and 30. Now we will see the 2D indexing. Seventy, 80, 90 and 100. Row 1 and column 2. Here are 1, 2 and this is 90. First 0th row, first row and 0, 1, 2 element. This way we can use 2D indexing and get the item from the NumPy array. Now we will see the mathematical operations. One of NumPy's biggest strength is vectorized operations. NumPy comes with hundreds of built-in mathematical functions. We don't need to import math anymore. We have sum, max, min, and statistical functions like mean, which is average, and STD, standard deviation. When using these functions on multi-dimensional array, you can specify an axis. Axis 0 is the column vertical and axis 1 is the row horizontal. If you omit the axis, NumPy treats the entire array as a single flat list. Let's create an array. One, two, three, 4, 5, 6. So this is the ARR.sum, which is calculated the sum of all the items. Mean axis 0, so it calculated the mean at 0 axis, and this is the max. So np dot so we are going to calculate the square root. So it's like this, np dot power and ARR and 2. So this is going to calculate the power of 2. 2 into 2 equal to 4, 3 into 3, power of 3 is 9, and so on. More examples. A equal to np dot array 1 to 3, 1, 2, 3. B equal to np dot array 4, 5, 6. 4, 5, 6. Now we can calculate print A plus B A minus B A star B and A to the power B. So all these values are calculated fast. Now we'll see the statistical function. Print A dot sum print a dot mean. So first will give the sum, and then second is going to give the mean value. This is the sum and this is the mean. Then there are other function max and min. Max and min. Now we will see how we can generate the random number. Random number generation is used in machine learning. So let's see how we can generate the random numbers. NP dot random dot rand 3 random numbers here. And if we want to generate the int only, rand int and 1 200 and step 5, and size is 5. NP dot random randint lower, higher and size. Lower is 1, higher is 100, and number of items to be generated is 5. 1 2 3 4 5. So it generated 5 items. ARR equal to NumPy dot array 10 3 3 5 9 100 9 3 2 100. So this is our NumPy array, and we would like to sort it. Then we can do this like this: print array dot np dot sort and array. So it is sorted array. How we can do a Boolean filtering? NP greater than, or let's see 10. So is saying false, false, false. And to get the item, we can do like this. Now using the multiple condition, ERR is greater than and ARR is less than 100. So we have to use and ampersand instead of and during the filtration. Now we will see how we can filter the even numbers. ARR and ARR percentage to equal to 0. And it should give the even numbers. Real world example, salaries. Salaries is equal to np.array So these are the salaries. So these are salaries NumPy array and high paid salaries greater than equal to print high paid. So this way we can do a filter 50,000, 60,000, 70 and 1 lakh. So in this video we have learned NumPy in details. Congratulations, in just 1 hour you learned what NumPy is and why it's powerful, how to create and manipulate arrays, indexing, slicing, math operations and real world use cases. Next, I recommend learning pandas, matplotlib and scikit-learn. If you found this video helpful, please like, share and subscribe for more Python content. Happy coding!